Now before we get started, I just want to say that when this video gets 100 likes and 100 subs, I'll make a follow-up video where I'll go into more details and I'll release the 3D files for free. Now back to the video. Here are all the parts that I designed and printed for this project. The main part of the hammer, the side plates, the hinges for opening and closing the side plates, the roof, the spike on the roof, the grip, the pommel, the spikes that come out, the hinges that open and close the doors, and last but not least, the hinge for moving the spikes. Starting off with the grip, there's honestly nothing too special about this. It connects to the main part of the hammer using M5 screws. One thing that is nice about this is that I designed it with 3D printed threads, so you can connect the pommel directly to the grip without using any additional screws or glue. And yeah, I know what this looks like. Here we have the side plates, and there's not much to talk about here. I've actually made a video on these before. I'll leave a link in the description if you want to go check that out right now. The only thing I've changed from that is I'm using these L-shaped hinges instead of straight ones. This way you get some extra clearance when it opens. Now here we have the roof of the hammer. I split this up into 3 just so that it'll be easier to install once we have the plates on. And just like the grip, I designed this with 3D printed threads so that you can install the spike without any additional glue or screws. So if you don't like the design of my spike, you can then design your own and use that instead. Up next, we have the main part of the hammer and the spike movement. Now the way the spikes move is I have a servo in the exact center, which rotates from 50 degrees to 170 degrees. And as it does that, it pushes on these arms, which moves the spikes outwards. Now the way I'm controlling the servos is through a potentiometer. When it's all the way at the bottom, it pushes the spikes outwards. Now a nice thing about this design is that even if this hammer is upside down or sideways, nothing moves or falls apart. That's just the way I designed it from the start. There's no screws holding the spikes in place. Here we can take a better look at how exactly the spike rail works. The spike just goes on the rail, and even if it's upside down, it's not going to fall. We don't really need to worry about friction on this because the parts are so small and light. Some closing thoughts. First of all, this thing is absolutely huge. You can see compared to my hand, it's much bigger. Second, the spike movement, that was really nice, really smooth. Upside down, sideways, that thing always worked. Next, the design itself, absolutely beautiful. I'm really happy with that. I'm not really an artist, but this thing did come out looking really nice. And now the plate movement. Honestly, that thing's pretty dog shit. I used cheap servos. In the future, I'm not going to be using these plastic horn servos anymore just because they are not that good. They don't return to the proper position. I'm going to be using ones with the metal gears. Moving on. But overall, I'm still pretty happy with this project. There's a lot of things I would do different in the future if I were to revisit this. But for now, I'm pretty content. If you liked the video, like it and subscribe. And thanks for watching.